Okay, quadratic sequences. It's not an easy lesson, but we're going to start off slow. Right, so just to wake you up, these are all linear sequences. Work out the nth term. After you've done that, I'd like you to work out the 100th term. Now, just to help you out, the first one, I look at the common difference. So I'll do 13 minus 8 or 18 minus 13. Yeah, and I know my difference here is going to be 5. Yeah, so I know it's going to be 5n. 5n plus what is 8? And it's going to be 5n plus 3. Okay. To work out the 100th term, I put in 100 in place for the n. So 5 times 100 is 500, plus 3 is 503. Okay. So my answer there should be 503. Pause the video, and I'll work the rest out. Show you the answers. Okay, good. Hope you got them right. If you don't, please go to the previous video. There's nothing too complicated going on. So this one here should be 6n plus 3. Right, now look at these sequences. These sequences are all accessible to you. You don't need any massive knowledge. Some of them are linear, some of them aren't. But you should notice them. So pause the video, see if you can work out the nth term from. They all come in handy. Now, let's go through this. Now, my first one is a linear sequence. Yeah, it goes by 2. So I know it's going to be 2n. But it's good to always check to make sure that it does consistently go up by 2, which it does. And it's going to be plus 36. Because 2 plus 36 is 38. My next one, again, my difference here is minus 100. And that's consistent throughout the whole sequence. So I know it's linear, so it's going to be minus 100n. Okay, and then it's going to be plus 200. Because to get from 200 to 100 minus 100. Right, my next one. 1, 4, 9, 16, 18. Now I'd still check the difference. My difference here is 3. My difference here is not 3. Yeah, so that tells me it's not a linear sequence. But looking at those numbers, 1, 4, 9, 16, 25, you should recognise them. And these are your square numbers. Okay, which means that it's actually n squared. Okay. Now my next one, 2, 5, 10, 17, 26. That's all. Let's do the same thing. My difference here is 3. The difference between 5 and 10 is 5. Oh, it can't be linear. But it looks very similar to C. In fact, if you look at it, it's always 1 above C. So it's going to be C plus 1. It's going to be 1 more than it. Okay. My next one, again, I look at it, I check my terms. This is 6. That is 10. Oh, it's not the same. Yeah. So it can't be linear. But again, look back at your C. Is there any relationship between C and E? Oh, it's twice as much. So it's actually going to be 2 n squared. So it's 2 lots of n squared, and n squared is C. Now this one is a little bit different. 0, 1, 4, 9, 16, 25. Now that is my square numbers again, but it's like 1 before my square number. So if you think about C, my previous term there would be 0. So it's still going to be something squared. It's not going to be n squared, it's going to be n minus 1. And of course you could represent it the other way. Now G's like, I always find it a bit funny that people get this wrong. Yeah, but the answer is just 5. Okay. If you want to be technical, it's really 0n plus 5. Okay, but what's the point of writing 0n? And if you look, my difference is consistently 0. So you could say it's a linear sequence. Right, let's talk about quadratic sequences. Every quadratic sequence in the world is in this form. an squared plus bn plus c. Okay. So we call the a, we call that your n squared coefficient. We call the b the n coefficient. Okay. Now this looks similar because if you think about all the quadratic stuff you've done with x, it's always like 2x squared plus, I don't know, 2x minus 5. And they're very similar, they really are related. Now what we need to do is we need to find the values of a, then we can find the values of b, then we can find the values of c. Okay, and there's lots of ways of doing this. Yeah, there's like some shortcuts we can do here and there, but I'm just going to teach you one way. Now let's focus on the first sequence you know. This is a quadratic sequence. It's your square numbers. Now, what I always like to do with all my sequences is I always like to find my first level difference. So here I've got 3. This one here is 5. This one here is 7. That one there is 9. You can go on. Now, because these are different, this tells you it's a lot not linear. It doesn't tell you it's quadratic just yet. Let's do your second level difference, which is essentially your difference of your difference. And I've got a 2, a 2, and a 2. And this is important because if I've got a second level difference, I definitely know that it's quadratic, you know, because they always do have the same second level difference. Okay. Now, what I want you to do is with your previous results, okay, these ones here, I want you to find out the second level difference of all these numbers. And I want you to have a look at the nth term. because we want to get to the stage where I can give you a sequence of numbers and you can work out the nth term. So do another second level difference and see if you notice anything. It's a lot better than if you discover it than if I tell you how to do it. So pause the video, please do this. Okay, I'm just going to skip ahead a couple of slides. Now let's work out the second level difference of this one here. Okay. So I've got a difference between 3 and 9 is 5, 6, 7, 8. No, that's not right. It's 6. And then this is 9, 10. So it's 10. And this is 14. And that is 18. Okay. And then we do it again for the second level. This is 4. Oh, that's 4. And this is 4. That's nice. So I'm just going to put a 4 and we'll put a ring around it. Okay. Now my one here, my difference here is 3. And my difference here is 5, 7. There is 8, 9. And you should notice that this one here actually has got a difference of 2. So I'm going to put my second level difference here of 2. Okay. And I'm putting a 1 there just to help us out. Now ask yourself, is there any pattern between my second level difference and my quadratic sequence? Need a bit of guidance. Look at your n squared coefficient. So is any relationship between 4 and 2 and the same relationship between 2 and 1? And what you should have noticed is that your second level difference is always going to be twice your n squared coefficient. Okay? So the number in front of the n squared is half that of your second level difference. So by logic, I think if this is a half, my second level difference should be 1. Well, let's test this out. So the difference here is 1.5. The difference here is 2.5. And this goes 3.5. And then 4.5. If I work out the difference here, I get 1, 1, 1. And look, 1 is twice of a half. And the same happens here, you should get 2. Okay? So if I'm working out my sequences, okay, that means I know what A is. I've got a way now of working out what A is. And we'll focus on B, N, and C at a later stage. But I know if I work out my second level difference, I halve it, I get A. So look at this one here. Work out what our value of A is. Let's do it. The difference between 3 and 12 is 9. The difference between 12 and 27 is 15. Okay. The difference between 27 and 48, that's going to be 21. Okay. If I work out my difference now, I get 6 and then 6. Oh, good, they're the same. That means we're doing something right. So if this is 6, I know that A is actually going to be 3. Okay. So I'm going to know that as 3n squared plus bn plus c, and we'll work out what bn and c is in a different. Okay, so this one here, let's see what we can work out. So we'll do the first level difference. So I've got 6, 10, 14, 18. I'll work out my second level difference, and this is nice because it's the same, because it's going to be 4 again. So I know my value of n is going to be, of an squared, is actually going to be 2. Okay. Now what we do is we do something slightly different. Yeah. So I'll write the sequence 2n squared. Okay. And I'm going to write it underneath here. So I know 2n squared, so 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Okay. 3 squared is 9 times 2 is 18. Okay. And then we subtract it. Okay. So actually I'll subtract top from the bottom. So minus 1 minus 2 is minus 3. 5 minus 8 is minus 3. 15 minus 8 is actually minus 3 again. Okay. Now what this little bit at the bottom is, that actually gives you your value of bn plus c. And it's actually a really nice one, because now I know that bn plus c actually equals minus 3. Okay. And I already know that a is 2n squared. So I know my sequence is going to be 2n squared minus 3. And we can check if it works. Yeah. So if I put n as 4, and I do 4 squared, which is 16, times 2, minus 3, I get 29. So that's good, it works. Yeah. This one here, go. See if you can work out the nth term. These are actually nice ones I've given you. Pause the video, please. So first of all, you work out your first level difference. Okay, which we've got 9, 15, 21, 27. And then you work out your second level difference, okay, which is 6. So if that's my second level difference is 6, I know that my my 8 is going to be 3, because it's got to be half. Okay. So what I would do is I would write out my sequence straight away if it was in your book. So I'd write the first one, which is 5, 14, 29, 77. And here, I'd write the sequence 3n squared. Okay. So let's do it. 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. And then you subtract. 5 take away 3 is 2. 14 take away 12 is 2. 29 take away 27 is 2. And this works out your bn plus c. So I know my sequence now is going to be 3n squared plus 2. And again, we can see if it works. So let's say I choose this one here, which is my fourth term. And I type into my calculator 3 times 4 squared plus 2. I should get 77, which I do, which is nice. Right, this one here, go. It's going to be a bit quick for this one. First level difference, second level difference is 4. So I know my n squared is going to be 2. I've just done it quick here. I've written out my n squared. I've written out the original sequence again. I've subtracted, and it's 1. So that means my sequence is going to be 2n squared plus an additional 1. Okay. These are all nice quadratic sequences. Go, work them out. Please work out the nth term. Pause the video. Okay, here's your answers. Now, of course, the objection you might say is really, well, hang on a minute, so you told me that all of it is an squared plus bn plus c. And technically all of these, they've all just got an squared plus c. And that's because I've been nice and in all these b's are really 0. So we're going to do one here where it doesn't happen. So try it first and see what you get. So start as you normally would do. So I'd work out your first level difference. I'll work out your second level difference, which is 4. So I know my a is going to be 2 now. Yeah, same as before. Write down the original sequence, write down the sequence of 2n squared, and subtract. Now, if you look here, 2, 5, 8, and 11, yep, that's not a number, but that looks familiar, 2, 5, 8, 7, 11, and that actually is a linear sequence. So what I'll do here is I'll actually work out the nth term. So the difference here is 3, 5, 6, 7, oh, it's 3 again. 3, so I know that's going to be 3n minus 1. Yeah, so this one here is 3n minus 1. And remember, this is the same as bn plus c. So I know my sequence now is going to be 2n squared plus 3n minus 1. Okay, work out the nth term, please. Work out the difference. This one here is 8. Next one is 12. That one is 16. I'm going to do one more just to be safe. 15 minus 32 is 20. My difference here is 4. My difference here is 4. Good. My difference here is 4. So I know this is actually going to be 2n squared. So I'm going to write my sequence again. Minus 4, 4, 16, 32. I'm going to write the sequence of 2n squared, which is 1 times 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And then we subtract them. Minus 4 minus 2 is minus 6. 4 minus 8 is minus 2. 16 minus 18 is minus 2. And that is 0. Good. And so this is a linear sequence, so really let's do it properly, bn plus c. So look at the differences here. That's up by 2. So it's going to be 2n. 2 minus 8 is minus 6. So when I combine it all together, I get 2n squared plus 2n minus 8. Good. The last one. All the same as before. My difference there is 8. My difference here is 16. My difference here is 24. Let's do one more. So 6 minus 44 is 32. And then I'll do my difference again. That one there is 8. This one here is 8. And that one there is 8. Oh, so that's nice. And then I know it's got a second level difference. So I know it's going to be 4n squared. So I'll write my sequence again. Minus 4, 4, 20, 44. And I write my sequence 4n squared. So 1 squared is 1 times 4 is 4. 2 squared is 2 times 4 is 16. 3 squared is 9. 9 times 4 is 36. And 4 times 4 is 16, times 4 is 64. Let's take it away. Minus 4 subtract 4 is 8. 4 minus 16 is negative 12, so that's minus 8. 20 minus 36 is minus 16. And 44 minus 64 is minus 20. This is Bn plus C. Nice linear sequence. The difference between minus 8 and minus 12. There's a lot of minuses going on here. Okay, but that's actually minus 4. Minus 12 and minus 16 is minus 4. Oh, good, that's a nice linear sequence. How do I get from minus 4 to minus 8? I actually have to subtract 4 again. So the Bn plus C is minus 4n minus 4. Yeah. So if I put all of it together, I get my 4n squared from the original bit minus the 4n minus 4. That's not confusing at all with the amount of 4s in it. Okay, good. Got some questions. Go through them. Ignore that textbook. Pause the video. Here you go. Here's your answers.